Okay, guys, so in the last video, we've learned how to find the greatest common factor of just numbers, but now we're going to add variables and combinations of numbers and variables. So let's start with just the variables themselves. So there's one rule that you should definitely put on your note card, which you should know. So whenever you find GCF of any two powers of x, so you have something like x to the power n, x to the power m. So you have like different powers, right? So GCF of these will always be the smallest number, smallest power. Okay, so if it's something like, so let's say I want to find GCF of x cubed and x to the 5. So you just pick whichever one is smaller. Okay, so you look at the powers and it's a 3 and a 5, and which one is smaller? 3. So that's the one you take. So that would be x cubed. Okay, so something like this, just as a reminder for yourself on your note card, would be great. Okay, so what about if I find GCF of something like x to the 4th and just x, and x has no power? So if a variable has no power, what that means is that the power is going to be 1. So we can always stick a power 1 in there, and that's the same thing because raising to the power 1 does not change the number. And now we're just looking at the two powers and we're trying to find which one is the smallest, and that would be a 1, obviously. So that's just going to be x to the power 1, which is the same as x. Okay, so that's basically what happens with variables. Now, if you have combinations of numbers and variables, you do them separately. You do the numbers separately and the variables separately, and then you just like multiply them together. So just I'm going to consider a couple of examples. So let's say we want to find GCF of 3x squared and let's say 20x to the 4th. Okay, so first we're going to start with numbers. Okay, so we're going to start with 3 and a 20. So we're going to put 3 and 20 over here, and then we're going to list, as you remember, all possible factors of each. Always start with 1, and 3 does not have anything else other than 1 and 3. So all I really have to know whether 20 is divisible by 3 or not, right? And so at this point, you can just use a calculator to just see if that works, right? So I'm just going to go over here and okay, 1 second. It's got to be larger. All right. So I just want to see if 20 is divisible by 3. Actually, it won't be, because if you add 2 plus 0, that's a 2, and 2 is not divisible by 3. But if you want to check it, you can always do this. Okay, so 20 divided by 3. Okay, you can see that there are a point. The moment you see point and some decimals after that, that means it's not a factor. So 3 is not a factor. So 20 will have other factors in there, but we don't care because we just want to see what they share. So it looks like they only share 1, which means they're relatively prime. So GCF of them is just going to be 1. Okay, and then what you find is that, so you're gonna put 1, and then you look at the variables and look and compare the powers. You always take the smaller of the two powers. So that's just gonna be 1x squared, and remember that's really multiplication here, so that means it's x squared. So that would be the GCF of 3x squared and 20x to the 4th. Now let me take a look at a couple more examples. So let's say I want to find GCF of 15x and let's say 45x cubed. Okay, so let's say I want to do that. So first I need to find the GCF of numbers. So how do I do that? I'm going to list all the factors here. So 15 is, of course, 1 and 15. So those are obvious. 15 is not divisible by 2 because it doesn't end with an even number. But is 15 divisible by 3? I think we may have done that already. So yes, 3 and 5 will be there. And then you can check that there's really nothing else. So you can check because it's not divisible by 4. It is divisible by 5, but we already have it, so there's nothing else that's going to be there. So those are the only factors. Now 45, don't have to list all of them. Only list the ones that they may share with the 15, because you're doing extra work. So of course 1 is going to be a factor. So how about 3? Is it possible that they share a 3? Okay, to check that out, you take 45 divided by, that would be nice if you could divide, not multiply, divided by 3, that's 15. Yes. So they do share a 3, and oops, they also share a 15. And now you already know that 15 is going to be GCF, right, of these two, because there is nothing else that's larger. So they share these two, and definitely that's the GCF. Okay, so then this is going to be 15. And as far as the variables go, okay, so this is x to the power 1, right? Remember, if there's no power, just put a 1. And then we compare the powers and we take the smallest of the two. So that's just going to be x to the 1, which is just x. So the GCF would just be 15x. Okay, so just looking at one more example where you have maybe also, besides x, is also y or something. Like they really started to get on your nerves here with so many different ones. Okay, so let's say you have something like 12x squared y, and then maybe you have, I don't know, 18x y cube or something like that. Okay, so you're trying to find GCF. Okay, so you got to do each one separately. Let's do the numbers first. So 12, 18. Okay, so 1, of course, is going to be a factor. 12, of course, will be a factor. 2, yes. So if I take 12 divided by 2, is that divisible? Yes. We get an integer. Okay, so 6. 3, 12 is divided by 3 and gives you a 4. So yes, 3 and 4 are factors. There's nothing else. You can check that out. That's it. Now let's do 18. So 1 is definitely a factor. It always is. And 18 is definitely a factor. That's not going to be what they share, but you know. Let's see, how about 2? So 18 is divisible by 2, yes, and you get a 9. So 2 and a 9 are factors. How about 3? So 18 is divisible by 3, yes, and that gives you a 6. I don't think there's going to be anything else. You can check it out, but you will see that there's nothing else there. So if you compare these two lists, you will see that 6 is the largest factor they share. They do share a 3 and they do share a 2 and they also share a 1, but the largest one they share is a 6, and that's what you want. So the GCF right now is just going to be 6. Now let's try to figure out what about the variables. So let's do x with x. So this x, I have to put a 1 because I have to see which power is smaller. So I have 2 and I have 1. The smaller one is obviously 1. So that's just going to be x to the power 1 or just x. Okay, so that's the x. Now let's deal with the y's. Now y doesn't have a power, but you can always stick a 1, right? And now you're going to compare 1 over here and 3 over here. And you take the smallest one of the two, and that would be 1. So that's 6xy. Okay, so that's how you find GCF of mixes with numbers and variables, guys.